So it's now time for our final short paper of this current conference. And Luca will be presenting on the existence of intelligibility in the natural world. How should we understand laws of nature from a philosophical and theological perspective? Brilliant. So thank you, Luca. Over to you when you're ready.
Very good. Thank you. Yes, thank you very much, first of all, for the presentation. So in this paper, I will discuss the existence of intelligibility in the natural world, and I will attempt to answer the question, how should we understand laws of nature? I will start with a quotation from Thomas Aquinas, who advocates the existence of a principle of rationality within the natural world, which pertains to all creatures, not solely to human beings. He wrote, "Created nature is nothing other than the ratio of a certain art, namely the divine, inscribed in things, by which things themselves move to a determinate end, just as if the master shipbuilder could impart to the wood something from which it could move itself to taking of the form of the ship." An important question to ask is whether we are able to pinpoint of what such a ratio of divine art inscribing creation consists of. The Christian theologian Tanzela Nitti has commented on this quotation by Aquinas and has argued that this principle is reflected by the existence of intelligibility in the natural world, manifest by the existence of laws of nature in creation. In particular, the mathematical formulae of physical laws can be understood as formal causalities of the objects that are studied by physicists, for example, the physical law which govern the phenomenon of gravitation. And it can be argued that they represent the forms which God has imprinted in created matter. In this sense, God can be seen as, quote, as the dator formarum, giver of form, responsible for the multiplicity and the harmony of the form existing in nature, in the organic world as well as in the world of living beings. Similarly, Heller reflects on the notion of information in the natural world, a concept which can be easily blended with the philosophical notion of form. Heller writes, "The substance of the universe is not only mass energy, but also information, which relates to the philosophical concept of form. A certain amount of information is coded within the structure of nature. Science deals with its decoding. Each discovered laws of nature, for example, the physical law, which physicists express with a mathematical formula, is information which we have been able to read. In other words, the existence of universal laws of nature, such as the mathematical formula for the laws of physics, to which creation obeys, reflects the presence of some sort of intelligibility imprinted within the natural world. Thus, we can think of the law of nature as being a reflection of the creative logos in the natural world. A scientist has the privilege of encountering the trace of the divine through the discovery of the intelligibility within creation. Let's now reflect on the way in which a scientist may discover a law of nature. A scientist asks a specific question about the natural world by carrying experiments and receiving specific answer, data, during the experiment. For example, the scientist has to perform some experiment and interpret the data, try to formulate the law of nature, and then in this way, he will develop some theory. He will know, for example, that two particles with opposite charge are attracted to each other, particles with the same charge instead repel each other. And we know that these interactions are a function of the distance of the particles. It is interesting to reflect on the meaning of data collection and interpretation, given that this is such an important task of scientific research. The English word data derives from the Latin word datum, which means that something is given. Theologically, we can assume that something which is given has also been created. and in some sense as being given to us as a gift. The Latin verb used with datum is in fact dare, which means to give. It is as if a scientist is reading the book of nature, a concept used by different theologians in the past, for example, Bonaventure, and then by reading this book of nature, he discovers some things, some data, which then needs to be analyzed and interpreted. Concerning this point, Tanzella Nitti wrote, the scientist is surprised by his or her capability to dialogue with physical reality. He or she knows that nature can be understood in terms of mathematics, that his behavior depends on stable laws in time and space, and that is made of a rigorously identical elementary particle and of compounds having physical and chemical properties which follow rigorous ordering structures. All of these things reveal a kind of underlying foundation of rationality. The perception that physical reality is a subject open to dialogue with the scientist is strong in not a few researchers. For example, Heisenberg became aware of the central order of the world with the same intensity as they become aware of the soul of another person. In particular, Heisenberg had a dialogue with Wolfgang Pauli in 1952, and he used this expression, the soul of another person, when discovering this reality. The existence of this dialogic component between the scientist and the natural world is evident when the scientist first asks questions to, and second, receive answers from the natural world. The created world displays some intelligibility to the scientist as a consequence of the fact that there are specific laws of nature which govern natural phenomena. However, concomitantly, we should not forget that physical laws describing natural phenomena are merely human attempts to describe the laws of nature. Physicists observe the behavior of the natural world and attempt to suggest formulae which explain the observed data, but we must remember that these mathematical formulae are only a work in progress to describe the natural phenomena. Following this line of thought, the physicist Paul Davies states, it is important to understand that the regularity of nature are real. The existence of the regularity in nature is an objective mathematical fact. On the other hand, the statements called laws that are found in textbooks clearly are human inventions, but inventions designed to reflect, albeit imperfectly, actually existing property of nature. Without this assumption that the regularities are real, science is reduced to a meaningless charade. In other words, we can say that the natural world is intelligible, and this grants the foundation for the scientific activity. But there is something which is destined to remain ungraspable and ineffable to the scientist. I will now bring some examples which demonstrate that the theories proposed by physicists to describe laws of nature are nevertheless only provisional. And this word was used yesterday by Mark Harris in his talk. Thus, the physical laws which we read today in physics textbooks could be improved in the future as a result of possible further advancement of scientific research and the discovery of unexpected data which will need to be explained. From this point of view, I want to argue that there is a strong similarity between the methodology adopted by scientists and the approach used by theologians in their research. Both, in fact, use cataphaticism and apophaticism in their truth-seeking activity. Before continuing, however, we need to define these terms. The use of these two expressions, cataphatism and apophaticism, derive from Christian theology, especially from the theological reflection of Pseudo-Dionysius in his development of mystical theology. Cataphatic theology consists of an affirmative discourse on God, for example, the use of comprehensible concepts, symbols, images in relation to the divine. Some examples of cataphatic description are the portraits of God manifestation in creation, for example, the intelligibility which is discovered by scientists in the natural world. Other examples of cataphatic moments are biblical revelation and also the life-changing effects of sacraments. Conversely, apophatic or negative theology adopts a negative discourse on God. We can affirm, for example, that God is not passible. In this way, we endorse divine impassibility, or we can say that God is not mutable, and in this way, we endorse divine immutability. These apophatic statements reject affirmative notion of God, since there exist no words to fully describe God. Therefore, even our cataphatic statements about God are somehow defective when viewed from the divine perspective. Apophaticism grants divine transcendence and divine ineffability, and it is important for theology because our human language has important limitation in describing God, and this also confirms that the divine is, after all, ungraspable and ineffable to human beings. For a correct theological approach, therefore, we need both a dialectic of cataphaticism and apophaticism for having a discourse on God. We can pronounce affirmative statement in relation to God, but we also need to admit that we cannot entirely grasp fully what this statement means, because they are in actual fact ungraspable. And we will see now that scientific research adopts also such dialectic. And my argument is consonant with the claim proposed by the Christian theologian Cunningham, who described the never-ending process of scientific discovery as a combination of cataphatic and apophatic approach. He writes, all scientia involves, without doubt, an apophatic and a cataphatic moment. We posit a primitive term, and doing so we trust. But in so doing, we know we fail to capture. Cunningham also writes that there are simultaneous moments of the cataphatic and apophatic, which all knowledge entails, and all the scientia is a marriage of discourse, a concept of effort that forfeits imperial ambition, for scientia seeks engagement, not subsumption, not eradication. It is a marriage that doesn't seek the purely isolated, it doesn't seek the purely isolated or the reduced. In this quotation, Cunningham doesn't refer to science merely as a modern experimental science, such as modern physics or biology, but to all truth-seeking activity which aim to gain knowledge within all disciplines. And of course, we should not forget that within the medieval framework, theology was considered the queen of all sciences. In our times, there are still many people who endorse scienticism, unfortunately, namely the idea that only the scientific method can provide truth about reality. Arguably, scientists emphasize the cataphatic aspect of scientific research and neglects completely the apophatic moment of scientific research. Let us, for example, analyze this book by scientist Jerry Coyne, entitled Faiths versus Fact, Why Science and Religion Are Incompatible. Clearly, the title already reveals that for the scholar, science and facts are indeed synonymous. And facts such as discovery of the intelligibility in the natural world for him are positive statements, and thus they represent cataphatic moments in scientific discourse. And the title of Coyne's book excludes a priori a role for apophaticism in scientific research, given that science for this author deals with fact. The implication of this book is that apophaticism applies only to religious discourse, since for this scholar, religion doesn't deal for him with facts, but with faith. As you can see in the commercial website which promotes the sale of this book, it can be read that the author lays out in a clear, dispassionate detail why the toolkit of science based on reason and empirical study is reliable, while that of religion leads to incorrect, untestable, or conflicting conclusion. Clearly, this shows that, according to Coyne, scientific research is solely a cataphatic activity, whereas religious discourse and theological research are apophatic enterprises. Let's have a look now about the apophatism in scientific research, and I will take the example of the laws of physics, in particular the law of gravitation. Every student of physics knows that the Newtonian formula which describes the law of universal gravitation is F times equal to G times m1 m2 divided r squared. F is the force, the gravitational force, m1 m2 the two masses of the two objects, r is the distance between the masses of these objects, and G is the gravitational constant. However, this mathematical formula is simply a human invention following the intuition of Newton and Hooke, and is designed to represent through mathematical language the specific laws of nature which explain the phenomenon of gravitation. Long time after Newton, Einstein rewrote the formula of gravitation in a different new form using the relativistic framework. In particular, Einstein predicted that the higher the speed of an object movement, the higher will be its mass, to the point that if the body is moving at the speed of light, its mass will be infinite. Einstein also demonstrated that the mass and energy are interconvertible, as you know from the famous equation E equal mc squared. Newton would have never imagined this phenomenon, and he wouldn't be able to explain them. Instead, Einstein provided new mathematical formula which improve the description of the laws of nature in relation to gravitation. And he was able to explain this apparently strange phenomena. This shows that improvements on the laws of nature are always needed to describe more accurately natural events, and the improvement of the accuracy of our scientific descriptions is a never-ending process. In this way, I will now pass to the second example, which shows that even if a physicist is able to pin down perfectly a physical law by writing the exact mathematical formula which describe all aspects of the phenomena, something will still remain ungraspable to the scientist. And this is because different scientific discoveries have demonstrated that the laws of nature are not immutable and have actually evolved since the Big Bang. Already the physicist and Nobel laureate Dirac in 1937 noted that some constants, such as the gravitational constant, which I showed you earlier, can change over time. The result implication is that given the timeline of cosmic evolution, the gravitation constant can be thought of, after all, not as a constant. In agreement with Dirac's intuition, further experimental studies have suggested that constant of physical laws, such as gravitational constant for the universe, but also the electromagnetic fine structure constant, have changed in their value since the Big Bang. Very recently, an experimental study led by John Webb has shown that measurement of light emitted from a quasar located approximately 13 billion light years away has revealed that there has been a spatial rather than just temporal variation in the fine structure of the fine structure constant in time. And on the top right of this slide, you will see the formula of the fine structure, which is a constant used in some physical law which describe electromagnetism. And the fine structure constant is a dimensionless number and is calculated from the speed of light, Planck constant, and the electronic charge. Webb explains that in his research team found a hint that the number of the fine structure constant was different in certain regions of the universe, not just as a function of time, but actually also in the direction in the universe, supporting this idea that there could be a directionality in the universe. Thus, the universe may not be isotropic in its laws of physics, one that is the same statistically in all directions, but in fact, there could be some direction or preferred direction in the universe where the laws of physics change. And please note, where the laws of physics change. Ilya Prigogine and Stuart Kauffman are two scientists who have endorsed the evolution of physical laws during cosmic evolution. In his famous book, Order Out of Chaos, the physical chemist and Nobel laureate Prigogine explained that the laws that govern the universe are not stable or permanent. Similarly, Kaufman tried to answer the question, which is the title of a book chapter, beyond Pythagoras, must we have foundations? And he answered negatively to this question because he believed that the evolution has enabled the formation of new constraints for further evolutionary paths, so that, quote, law-like behavior can emerge from enabling constraints. Furthermore, Kaufman provides additional evidence to support his thesis that physical constants can change during cosmic evolution. So it's clear that different studies have shown that laws of nature have evolved during cosmic evolution. And in turn, cosmic evolution induces us to reflect on another type of natural evolution, namely biological evolution. Nowadays, we know that some biological species have persisted over time. For example, crocodiles have looked exactly the same for 200 million years. Similarly, it can be inferred that the laws of nature, which have emerged during the process of cosmic evolution and that have persisted for a long time, also have persisted for a long time without changing. And the timeline of biological evolution, of course, represents only a tiny fraction of cosmic evolution, but the analogy between the two types of natural evolution are support, as I show by some scientific evidence, and they support my argument. This is in line with the philosophical perspective of Hans Jonas, who proposed that the physical laws are not pre-established, but are rather the result of process of cosmic evolution, which lead towards the achievement of stable harmonic structures. In other words, like the crocodiles that have not evolved and changed in the last 200 million years, so we can imagine that there are stable laws of nature. For example, E equal mc squared might represent a stable law of nature that have been discovered by scientists. The fact that physical laws and all their constant can evolve and can change adds nevertheless another level of ungraspability and ineffability in relation to the scientific study of the laws of nature. This, I argue, provides additional evidence to support the fact that scientific activity, like in the case of theological research, is by definition not only cataphatic, but also apophatic. And I will now conclude my paper by providing some reflection, theological reflection, in my attempt to answer some important questions. These are, in my opinion, some important questions we should try to answer. Can we ascribe any role to sin in relation to our inability to grasp precisely the laws of nature, independently from the fact that we are adopting a dialectic of cataphaticism and apophaticism? What are the theological implications resulting from the fact that when scientists discover intelligibility of a specific natural phenomenon, they concomitantly cannot grasp entirely the law of nature that they are studying? What does this tell us about the presence of divine trace in creation? So in relation to the first question, it can be argued that sin constitutes a contributor factor that could explain the lack of our complete and perfect knowledge of the book of nature, which is read by scientists. And some medieval theologians, like Bonaventure, have emphasized that sin had a negative effect on the human understanding on the book of nature. You can read here a quotation, but the point is that Bonaventure explained that the book of scripture, which is read in parallel to the book of nature, helps to heal the deleterious wounds of sin, which have been weakened, which have weakened our human knowledge of the natural world. And you can read that he wrote that there was a need for another book, the book of scripture, through which the previous book, which is the book of nature, had to be enlightened in order to acknowledge the true meaning of things. In response to the other theological question I asked before, I propose that two theological approaches could be used to demonstrate the presence of divine traits in creation. The first method consists in adopting a Platonic Aristotelian perspective, according to which creatures participate and are drawn towards a union with God. And the second refers to the presence of God's traces in creation through the effects resulting from incarnation. St. Albert the Great has reflected on the celestial hierarchy, one of his writing of Pseudo Dionysius, and in his prologue of this text, St. Albert reflects on Ecclesiastes 1:7. All streams flow into the sea, yet the sea is never full. To the place the streams come from, there they return again. The teaching of this biblical passage in light of Pseudo Dionysius is clear. Everything in creation has his teleos, a full union with God. God is the Alpha and the Omega, as exemplified by the fact that water flows from the river to the sea and eventually returns to the river. And you can see here a sentence I let you read, because I'm running out of time, about how she reflects about this sentence. It's clear that Pseudo Dionysius theology endorses the Platonic notion of participation, according to which there is a hierarchy of beings, an increasing participation in God, which is parallel to the ascending complexity of creatures. In the case of inanimate objects, the participation is minimal, but is still present, and the participation in God is more evident in living beings, and it reaches its apex in human beings, given our rationality. According to this view, angels are even more perfect than us, and thus display an even higher level of participation in God. So this is, very medieval kind of view of hierarchy of being. This is a couple of last slides. This is the second point, instead, how the reflection of incarnation can demonstrate the existence of traces of the divine, and the theological implication which result from incarnation can also, I argue, help to answer this question. And I propose that the presence of this intelligibility in the material world of creation is the consequence of the fact that the Word became true flesh. And the mystery of the two natures of Christ, human and divine, united in his person, bears some analogy with the scientific discovery of the phenomenon of light. For example, you can see in this quotation, the physicist Alfredo Suzuki writes that light has these two characteristics intrinsically. It's an electromagnetic wave and a particle at the same time. And then he compared the divine nature of Jesus Christ with the wave-like nature of physical light, because he left the glorious court of heaven and came to earth to carry with him life to bestow on us. Instead, the human nature of Christ could be compared to the particle-like nature of light. Another thing I want to say is that Christ's human flesh, at least before resurrection, obeys laws of nature which are imprinted in creation. For example, Jesus, as a real human being, in agreement with the law of physiology, grew from being an embryo to an adult. He assimilated in his human flesh chemical components of what we ate and drink, of what he ate and drank, so create components from the natural world. And he also bled when he was nailed to the cross. He was wounded after a soldier pierced his side. And in this sense, the incarnation of God, who manifested in creation 2,000 years ago, through the true man Jesus, take place also through the obedience of the law to the law of physiology. So there is an eruption of the logos into creation, which arises from incarnation, and this validates, I argue, the laws of nature. And given that the incarnation can be seen as a divine eruption in creation through the logos, the implication is that creation is somehow touched by God, who is perfect holiness and perfect intelligibility. And is therefore inevitable that incarnation left a trace of the divine in creation. And I almost finished. So my perspective is consonant with Teilhard de Chardin, who described the sacralization of matter in creation as a result of the incarnation. He wrote in a meditation that through your own incarnation, my God, all matter is henceforth incarnate. So we can affirm that God's presence in creation is the direct consequence of incarnation. Through the advent of Christ, the supernatural becomes an aspect not only of humanity history, but also of matter and even the biological forces. In other words, the intelligibility in creation is the consequence of the fact that, quote, the word logos became flesh, and consequently, flesh became word or rational. So Cunningham explained also that the rationality of matter reflects the logos from which it came, and this is further revealed in its inevitable complexification and evolution towards intelligent life that could then reason about its origin. And this is the last slide with the conclusion. And I have shown that the work of scientists helps in discovering a sort of intelligibility within creation. This intelligibility allows scientists to enter into a dialogue with the natural world, and this enables them to discover laws of nature. For example, the mathematical formulas of the physical laws. However, I've also shown, against the perspective of scholars who endorse scientism, the scientists, after all, are forced to use apophatic language when they try to pin down physical laws, because the mathematical formula which they invent to describe natural phenomena should be considered a work in progress. Moreover, my argument is supported by scientific evidence which shows that the physical laws and their constants are not necessarily immutable and static. And I have used the dialectic of cataphatism and apophaticism to show the scientific research is consonant with the method adopted by theology. And I have argued that it is possible to discuss theologically the presence of God traces in creation, both through the use of a Platonic Aristotelian approach and also by reflecting on the effect on the incarnation. Thank you.
Thank you, Luca. Well, virtual round of applause. Thank you. Really great paper. Just contemplating now. We will open it up for questions. I just wondered if you could talk a bit more on something you mentioned right at the end, where you were talking about like God's presence in creation being as a direct result of the incarnation. And I just wondered if you could expand on that a bit more, because it kind of feels like it implies, and I might be misunderstanding, but it implies that God wasn't as present in creation before the incarnation, or does the incarnation give us the evidence? Could you expand for us?
I also thought about that while I was writing the paper, and it seems like that before incarnation, that was not that God traces, the divine trace in creation were not present before he was incarnate 2,000 years ago. So in answer to your question, I've been convinced by an argument of John Bear, who has argued that we don't need to understand incarnation only as something which took place 2,000 years ago. In fact, in patristic theology, you could think incarnation like nearly concomitant with the generation of the Son. So if you use that, I would say, Eastern Orthodox reading, you would argue that there is no such problem. The Son is, after all, eternal. It doesn't start 2,000 years ago. It started before. Otherwise, we will be we will endorse Arianism. So, but yes, I agree with you that you could argue that way and say that that could be a problem if you read incarnation like literally. But nevertheless, it became true, man.
Thank you. That's really. I'm going to be thinking about that, traces of God through the incarnation now. So thank you, Roger. You're next.
Yes, thank you for a very interesting talk, which has made me think. I wanted to ask why you stress this idea that of the non-immutability of physical laws. Although Dirac suggested that some constants change, this is generally regarded as the fruits of his old age when he was over the hill. People have looked for these changes and not found anything convincing. Even in these quasar studies. And even if there is some law which sums of the fine structure constant changed in some way as a function of time, that in itself is a physical law. But why do you need, I mean, I don't think it's valid, but I don't see why you need it anyway.
Okay, thank you. I see what you're saying. And first of all, I thought that using this argument, which I'm practically convinced that that physical laws can change, and I'm convinced also by the fact that I didn't bring other examples, but also from the Big Bang, at the very beginning, what I've studied, what I've read, is that there was almost like a disorder situation. The physical law perhaps were not as clear as they are now. So I'm actually convinced scientifically that there is an evolution of physical law which makes sense from the order emerging from chaos, which Prigogine used as well. Even though we haven't validated. I presented Kaufman and you know the evidence, other evidence, but my argument is to say that this our inability to perfectly define a constant as a constant shows that there is something which is ungraspable in scientific activity. Therefore, there is something apophatic. And he resonates with what Mark Harris yesterday said about the provisionality of science and theology, given the serious lecture we're having for this event. So I think the thing converging, but it's an open discussion. And to me, there is a big convergence between evolution, not only of biology, but also physical law. But we could talk more. But
I think it's dangerous to talk about evolution of the universe and evolution of biology in the same breath. In evolution of biology, there is some idea of purpose, of progress towards a goal, be that according to Dawkins or according to Desjardins. But I don't think if the universe changes, and perhaps it gets less dense, perhaps it gets less darker, I don't think there's any purpose to be found in that.
I could argue again using Hans Jonas' argument, which, by the way, I'm writing a book on that because that was on my dissertation on Hans Jonas' philosophical theological perspective. He argues that what persists is something which is harmonic. A lot of physical law, look, for example, the story of Arthur Eddington, when he interpreted the relativity, he saw some beauty in some physical law. And Hans Jonas also argued that there is a principle of harmonicity by which only what is harmonic persists. And he argued that the physical laws are not pre-existent, but develop to something which is harmonic and therefore stable. And you could argue it's a philosophical perspective, but it matches very well with some of the things I presented, like Kaufman and Prigogine. And so yes, I'm not saying that biological evolution is equivalent to physical law evolution, but I'm saying that there is an analogy, and perhaps it hasn't been discovered. I think if we will study physical law near the Big Bang, we will see a lot of anomalies. And I think that's the impression I'm having.
Thank you. Yes.
Thank you, Roger. Great question. Andrew, your hand's up next.
Yep, thank you very much, Luca, for a very thought-provoking presentation there. It's got me thinking about the different way in which particularly scientists can live with provisionality in their own domain and yet not live with provisionality in the theological domain, because they think, for example, the problem of theodicy, if that can't be solved, then we're not going to accept anything. And they expect absolute knowledge and certainty in that. And that got me thinking as well about, you know, where does the lack of our ability to fully comprehend things come from? Is it a lack of information, such as, you know, we have received imperfect revelation from God, or not imperfect, incomplete revelation from God, or with our understanding of science, we haven't got down to the level of detail or up to the level of detail that we need. So where does that level of ignorance come from?
Yeah. Well, you can answer to this question twofold. The first will be, okay, a first response will be more like within the limit of scientific investigation. You know, it is clear that we live in a world that is not deterministic. We have seen from quantum mechanics, we have seen from the inability even to capture a number like the pi number. You know, you will spend all your life to write all the digits that are after the pi number, and yet you wouldn't have written the pi number, right? So if you don't have the pi number written exactly, how can you make prediction of a sphere moving? It's impossible. So even within science, there is some kind of, I would say, imprinted unpredictability. That's what I would say. And, you know, even the three-body problem, non-linear equation, you don't have solution of all the equation. So there is something that you cannot get precisely. You can get approximation, but it's not precise. So this is the first answer. The second answer is theological. And I will use Bonaventure, the slide I showed quickly earlier, that perhaps is a consequence of sin. The fact that we are unable to read the book of nature. And therefore, we need the light of the book of scripture to make sense of the book of nature. And in that sense, that sentence I showed earlier from Suzuki, the physicist, is an example of a scientist that tried to understand reality with physics, but then is enlightened by theology. And I think both of these shows, as God is ineffable and incomprehensible, and it cannot be understood fully, so a scientist cannot fully understand the truth is studying.
Yeah, I wonder if the point about sin, you know, destroying our ability to understand the universe completely. I mean, I don't particularly agree with that. I think there's another thing here, that we are a created part of the universe, and we are never going to be able to understand it completely, even as a human species. It's not to say we shouldn't make endeavors to learn more. Which also says, you know, of the importance of revelation, and, you know, the fact that Suzuki you know, he could only come up with this analogy of light to the incarnation because of the revelation of the incarnation. He couldn't go from the nature of light to the nature of God absent that revelation.
I agree. I think the two need to kind of complement each other, and that's, I guess, one of the objectives of this meeting, is it? Of this, yeah.
Thank you.
Thank you, Andrew, and thank you, Luca. It's brilliant. Another really thought-provoking paper. So thank you ever so much. A final round of applause for you.